from Kearney, Nebraska. Smack dab in the middle of the United States, east and west, 1733 miles either coast on the Lincoln Highway. This is a commercial building up on the north end of town. It's 3,000 square feet. My name is Bill Sund. I was the installing contractor. Somebody else purchased the equipment. Not something I would have put in here, but you know, you get roped into those things, so you make the best of it. What leads me to the fan handler is I laid this thing out for 3,300 CFM. Found out that the machinery, the fan coil, or the packaged unit, as I would, I guess, call it, the packaged Bosch heat pump, only delivers about 3,000 CFM at very low static. With the 20-inch ductwork on it, it does have a very low static. So I got a hold of Richard, and he says, well, you put my modulating control on the EMC motor and you'll see a vast improvement. What I was having a problem with was the fan in the on position ran the EMC motor at such a low speed that there were pockets in the space that just didn't condition properly. By adding on the control and with the magic that this little thing right here does, the place absolutely snapped to and is absolutely the same temperature. It's wonderful. The humidity is under control now, and the people are very comfortable. There are no hot spots, no cold spots anymore. And that's the sensor that I'm showing you right there in the supply duct. There's a variable speed pump in the well. There's the monitor control for that. There's our 2-stage water valves underneath here for first and second stage. This is a 6-ton water source heat pump, a Bosch, and I'll show you the insides of it in just a minute. The control was an absolute snap to install. The only thing that takes a little bit more time than screwing on the older fan handler control is that it requires a motor change. Just to give you an idea of what's happening here, this is a Carrier total line thermostat, and it's the school model with the light sensitive control. The people go home at night, they shut the light out, the control goes into automatic night setback, the janitor comes in, turns the light on, it resumes the occupied period settings, they leave, it shuts off again. And with the sheet metal removed, you can see inside here, it's got a huge blower. It's a 1 horsepower motor. There's their motor from fan handler, Nail Smith motor. You can see the control is mounted right there on the removable access panel. You drop 2 screws out of that and the control stays inside. You can remove the panel. The panel up here is where the control is for the electric heaters and the transformer control for the machinery, and I've labeled it, the fan control transformer is here. You'll need a source for the 24 volts to run it, and then the rest of it's pretty simple. As you can see, the plug that used to go to the old motor is right there, not necessary anymore. The fan control plugs in very simply to the motor right there, and you're pretty well done. You run the sensor wires to it, 24 volts to the control, and you're cooking. The sensor is very important. You want to get it out of the mixing box, so you've got a good solid airflow and a good sample of what this machine's delivering, and you don't want to be in sight of the heaters, so radiant heat throws you off. The heaters are right here, There's a plenum that's 3.5 feet tall. It's a squared around. Then it goes to a 20-inch elbow. It turns, and out of the radius of the elbow, there's our sensor right in the bottom. Now, you sample all the way around the pipe or all the way around the duct, and make sure that you don't have a place where there's no airflow and there's no accurate sensing of the heat that this thing's putting out. The cooling will take care of itself. The heating is what's tricky. The air will stratify in your duct. So be aware of that when you're placing the sensor. The motor you can see right now is running on its low speed, and I'm standing a foot away from the motor, and it's pretty difficult to hear it. It's not chattering, doesn't make any noise. My description is it runs as smooth as silk. Only what I'd expect from fan handler. So I don't need to have monitoring hooked up so it can call me day or night. I don't need to use my smartphone to tell it what to do. I already used my smarts and told it what I wanted it to do. I checked it, it did it, I walked away from it. It looks like now it's called for a second stage. So when it actually starts, it's going to ramp up on the high-speed compressor, and we're going to see a pretty good spike in the way the fan motor ramps up. I want you to see that, and we'll listen over here in this return air hole to what the fan speed is doing as the machine comes on. And you'll notice that it doesn't have much of a delay with it. It'll follow the heat very quickly. Okay, the machine just started. We're going to move up a little closer to it here, and you can hear a little bit of the water sound. And again, the fan's running. I'm standing a foot away from the machine, and I virtually can't hear any air noise at all. You can hear the compressor changing pitch as it picks up the full load, and that usually takes about 30 seconds after it starts. But the water's been running, so the water flow is correct. You can hear in the background now the fan speed coming up. There's that wonderful sound we like. The motor's coming up to speed. You notice like in less than 30 seconds it's getting right with the program. It's not some chiphead sitting back in the factory saying, well, okay, after 2.5 minutes we'll do this, or after 3 minutes we'll do this, and then we'll see what happens, and you should like it. This is like spoon feeding a baby. It's going to get exactly what it needs, all the time, at the right time, forever. I told Richard when I ordered this control, and this is another thing you can do with fan handler, is you can tell them what you want the leaving air at maximum speed to be. Or I said, at 105-degree leaving air, I want the fan at high speed. You can say 93, you can say 110, 120. For those people that don't like drafts, that maybe it's in a nursing home and they're elderly people, they want to feel that nice hot air coming out of the register. Okay, with a heat pump, I'm here to tell you, you can deliver nice warm air for those people. And it will not be drafty on the shutdown because of the way the fan modulates, based on the signal it gets from the sensor. There's the Yahoo about fan handler compared to everybody else's product on the market. Okay, now the sound of the compressor's gone, thermostat satisfied. Now we're going to run out the residual heat in the system. As you can tell, the pitch has not changed on the fan motor at all. Just because I shut the machine down doesn't mean I gotta stop shoveling heat. There we go. You can just hear it start to back off. You've heard the same sound at altitude when they're flying in a jet airplane. They back off of the engines when they're ready for descent. This is doing exactly the same thing. And we're back to just about to idle speed, and we're stirring. Now we're going to stir the air until there's another call for heating. And I guess that pretty much concludes what we came here today to talk to you about. We said sit, spot, spot, sat. We gave it a bone, said you did a good job, and now we're going to walk away.